We're now going to look at some special sequences and series. The first one is an arithmetic sequence. So let's just read through what this says really quickly. And it says that an arithmetic sequence is a list of numbers with a definite pattern. If you take the number in the sequence, then subtract it by the previous one, the result is always the same constant. Then it is an arithmetic sequence. So let's write that mathematically. It's saying that if we take a term in the sequence, so let's just call it a sub n, and subtract off the term right before, which is a sub n minus 1, we're always going to get some common difference, some constant, same constant. For arithmetic sequence, they call that D. So D is called the common difference. Okay, this is one of our formulas for an arithmetic sequence. Let's use this formula to help us find some other formulas. So let's say we wanted to look at a sub 2. So by this, it's saying that I would take my first term or I would take a sub 2 is equal to, actually before I do that, before we do this, let's look at this. So let's say I wanted to find a sub n. Let's solve for a sub n here. A sub n is equal to, we can add the term right before it to both sides of the equation. So a sub n is equal to a sub n minus 1 plus d. So here's another formula. So I'm going to use this formula to get one more formula. And so if I was looking at a sub 2, by this formula, the second one we just wrote, this is equal to the term right before it, which is a sub 1 plus some common difference d. If I want to look at a sub 3, this formula is saying I'm looking at the term right before it, which is a sub 2, and then I'm adding my common difference d to it. So we're going to go in and we're going to use substitution. We know what a sub 2 is from above. So let's go back in and let's rewrite what a sub 2 is. So a sub 2 from above is the same thing as a sub 1 plus d. And then we would have this extra plus d. So simplifying this down, we have a sub 1 plus 2d. So now if I wanted to find the fourth term, a sub 4, by this second formula, it says I would look at the third term, the term right before it, and add my common difference d. And so if we can do the same thing that we had just done, let's go and use substitution. We know what a sub 3 is. Let's rewrite a sub 3 as a sub 1 plus 2d. So a sub 3 is the same thing as a sub 1 plus 2d, and then plus this d. So combining like terms, we get a sub 1 plus 3d. Let's do one more, and hopefully you can see the pattern going on here. So a sub 5 is equal to the fourth term plus a d. But we know what a sub 4 is in terms of a sub n and d. So we can rewrite a sub 4 as a sub 1 plus 3d plus d, which is the same thing as a sub 1 plus 4d. So we have a sub 1. Notice a sub 2 is a sub 1 plus d. A sub 3 is a sub 1 plus 2d. A sub 4 is a sub 1 plus 3d. A sub 5 is a sub 1 plus 4d, etc. And so another formula is that a sub n, this is equal to the first term, a sub 1, plus, notice that the number in front of our d value was 1 less than the term we're looking at. So it's n minus 1 times d. So these are 3 formulas that you're going to be using to help you with your different problems you have for this section. Maybe I should just write them here. So by definition, again, the term minus the term right before is equal to d. We said that a sub n is the same thing as the term right before plus d. And we just found another way to write this is take the first term plus n minus 1 times d. So let's look at some examples. So we have the following: find the nth term of the arithmetic sequence a sub n for the sequence 1, 4, 7, 10, ... And so notice here, we can see that this is an arithmetic sequence. To get from one term to another, we're just adding 3 to it. So we know what our common difference is. D is equal to 3. Well, if we know what the first term is, and we do, it's 1, then we should know what the nth term is going to be. So a sub n is equal to the first term, which is 1, plus n minus 1 times d, and d is 3. We can leave it like this, or we can clean it up. And clean it up, we could distribute that 3 and combine like terms. So if we distribute that 3, we get 1 plus 3n minus 3 is equal to 3n minus 2. And so let's just check it. We looked at the first term, a sub 1. We plugged in 1 wherever we saw an n in here. We get 3 times 1, which is 3 minus 2 equals 1. Okay, that's what we have here. Let's say we plugged in a sub 4. So we would have 3 times 4, which is 12. I'm not, sorry, I don't want a sub 4. I don't know why I said that. A sub 2. We have 3 times 2 is 6. 6 minus 2 is 4. That gives me my second term. A sub 3, that's 3 times 3 is 9, minus 2 is 7. Okay, etc. So we found the right formula for the nth term of the sequence. And so from there, we could find any term of the sequence. So if they said now find the 101st term of the sequence, well, we would look at a sub 101. So we would go in here, wherever we saw an n, we would plug in 101, and we would simplify. So we have 3 times 101, which is 303, and 303 minus 2 is 301. So I know the 101st term of that sequence, without listing out 101 terms, is 301. pull some more. So the following example asks us to show that the sequence is arithmetic, and the sequence it gives us is a sub n equals 6 minus 2n. So again, we got to go back to some of the formulas. And so by definition, we know that it's arithmetic if we take a term minus the term before, and we always get back the same number d. And so we're going to do that. Let's look at, we know what a sub n is. We're given that. Let's look at what a sub n minus 1 is. So if I looked at a sub n minus 1, I would just go back into my formula and I'm going to plug in n minus 1 wherever I see an n. So this gives us 6 minus 2. I see an n there. So n minus 1. So this is equal to 6 minus 2n plus 2. Which if I combine like terms, 6 plus 2 is 8 minus 2n. So let's look at the first term, or not the first term, a sub n, which we are given 6 minus 2n minus the term right before it. So we need parentheses around that whole thing, 8 minus 2n. Does this equal some constant d? So cleaning it up, we have 6 minus 2n distributing in the negative, we get minus 8 plus 2n. Is that equal to a constant? Well, it is, because negative 2n plus 2n, it cancels, and we have 6 minus 8, which is negative 2, is equal to d. So as long as you get a constant and you don't have n left in there, when you look at this a sub n minus 1, then you know that it is, in this case, an arithmetic sequence. So a sub n is arithmetic. Let's say you're given multiple terms of a sequence, and then you're asked to find what the formula for the sequence is. So let's say you're given that the fifth term is negative 2. And you're given that the 13th term is 30. Of an arithmetic sequence, and we want to find a sub n. We want to find the formula for the nth term. So when they give you multiple terms of a sequence and they ask you to find what that sequence is, we pretty much have a system of equations. And so let's look at one of those forms of the definition, and let's use that last one that we determined. So a sub n, we know the nth term of an arithmetic sequence is always equal to the first term plus n minus 1 times d. So if we are looking at the fifth term, then we know that a sub 5, this is equal to the first term plus 5 minus 1, so that's going to be 4d. But we know what that fifth term is. It told us it was negative 2. So our equation is negative 2 is equal to a sub 1 plus 4d. So here's one equation in our sequence. The other equation in our sequence, we've given the 13th term. You know, that's the first term plus 13 minus 1. That gives us 12 times d. And again, that 13th term is given to us. We know it's 30. So 30 equals a sub 1 plus 12d. So we have two equations and two unknowns. We have a system of, in this case, linear equations. And so we know how we can solve for our variables. So I would use the elimination method. Let's multiply -1 times one of them and then sum it to the other. Then we know the first terms are going to cancel. So if we multiply this by -1, and then we sum it to this. So -1 times everything in that first equation, that gives us 2 is equal to -a⁻1 minus 4d. So summing these two equations, 30 plus 2 is 32. Our a⁻1 cancels, which we wanted. 12d minus 8d, sorry, 12d minus 4d is 8d. And so we can tell here that our value for d is 4. So go back into one of our original equations and let's figure out what a⁻1 is. So we know that -2, right, is equal to our first term, a⁻1, plus 4 times d. But we just found that d was 4. So now we can solve for a⁻1. So we have -2 equals a⁻1 plus 16. Let's subtract 16 on both sides. We get a⁻1 is equal to -18. So knowing what a⁻1 is and what d is, we know now what the nth term of our sequence is. So a⁻n is equal to the first term, -18, plus n minus 1 times d, which is 4. I'm okay with you leaving it like that, but you could distribute that 4 and combine like terms. To save time, we're not going to do that right now. Okay, so summations of arithmetic sequences. So there's a formula, and I'll give you this formula too. You just need to know how to apply it. So if you were looking at a summation and you know it's an arithmetic sequence, you can look at n, how much we're summing n things, times the first term plus the last term divided by 2. So if we are looking at the sum of n equals 1, let's say 280 of 1/3 n plus 1/2. Okay, so we need to figure out certain things for this. This is what a⁻n is. So we know what a⁻n is. We need to know what we're summing to. We're summing to 80. So we know our n value in here is 80. So this is equal to 80 all times. It's telling me to take my first term. Well, let's look at what our first term is. We need to figure out what that is. So let's plug in and find a⁻1. So that's 1/3 times 1 plus 1/2. So I need a common denominator, which is 6. So I have 2/6 plus 3/6, which is 5/6. So I know that a⁻1 is 5/6 up here. Plus, now I need to look at the last term. And so my last term is 80. So I need to find what a⁻80 is. So I have 1/3 times n, which is 80, plus 1/2. So we have 80/3 plus 1/2. We need the common denominator again, which is 6. So we have 160 over 6 plus 3/6. And this is 163 over 6. So plus the 80th term, which in our case is 163 over 6. And that is divided by 2. Let's clean it up a little bit. Notice that this divides into our 80 40 times. Now we just have the numerator left. So 5, 6, and they already have a common denominator. So 5, 6 plus 163, 6. That gives us 168 over 6. Again, we can clean it up a little bit. I notice that 2 goes into 6 3 times. 2 goes into 40 20 times. 3 actually goes into 168, so we have 20. 3 goes into 16 5 times with a remainder of 1, and 3 goes into 18 6 times. So 3 goes into 168 56 times. Let's just multiply 2 times 56, and then we'll add a 0. So that's 12. So that's 112 plus that 0. So that's going to give us 1,120. So that's what we would sum if we had summed those 80 terms, first 80 terms of that arithmetic sequence. So this just gives us a shortcut on how to find summation. So that's arithmetic sequences.